everyone, and welcome to another episode of The Random Robot Does Something Random. So you may notice the large noise and the fact that the fan is not turning. This is not the normal operation for a heat pump, and you probably should shut it off. So with the system off, we can now take the access cover off, and it's going to be a potential of two possible problems. One, we've got a bad motor. Two, we've got a bad capacitor. So let's have a look and see what we have. So just for a visual inspection here, we got the capacitor here. And we've got a controller here. And there's the starter is right there. And before working on this, I'm just going to confirm that there is 0 voltage on the 240 volts. So I'm just going to take my voltmeter here and check the leads going into the starter. So I'm just going to confirm that we have 0 voltage coming into the unit. So that's going to be on the bottom side of this starter. So this is a dual capacitor. It's actually 2 capacitors, 1. This is the common point, and it's marked with a C. And I'm just going to check that there's no voltage between both sides of the capacitor. So now I know that the capacitor is safe to work on because we're at 0 volts. And I'm just going to set my multimeter to ohms, and I'm going to see if I can get a reading. So between the common point and each post, I should see the ohms increasing, and that's me actually charging the capacitor. And this has got me a little worried because it looks like the capacitor is good. So before taking off the leads, be sure to note the colors and which terminal are on. I'd recommend taking a picture of it. So I'm just going to uninstall the capacitor. I'm going to remove it from the unit, and it's just held on with one screw. So this is the capacitor removed from the unit. It is a dual capacitor. It's a 70 microfarad and 5 microfarad, plus or minus 6%. And we're just going to make sure that our voltage ratings and our microfarad ratings are a match on both. Now I'm going to measure it on volts again, just double checking that there's nothing on there. Always treat capacitors as live until you can prove they're not. So if they still have some residual voltage on them, just holding the meter on them will actually slowly drain them. Plus, using a resistor across them or shorting them out if you can get them down to a safe voltage. I recommend under 50 volts. So I've confirmed they're both dead. Now I'm going to set my meter to test for capacitance. So I'm just going to go between the common terminal and each terminal. I'm going to measure how many microfarads. And again, it should be plus or minus 6%. And you can see this is 65.9, so that's within the 6% range of the 70. And I'll just go for the other portion of the capacitor, the 5. And as you can see, it's only 3.7. That's beyond the 6%. So I'm suspecting that's the issue. And I'll just compare that with the new one. So my first reading is 72. And my second reading is 5.06. So the capacitor actually is bad, even though it metered out good. So, but let's just double check the motor while I'm here. So in this case here, I have a 4-lead motor. So the yellow would be the common, and I'm just going to go between the yellow and black and then the yellow and red. It's actually a 2-speed motor for this one. Most common motors on these outdoor units are usually a 3-wire unit where you just have the one winding. But I'm just going to show you what I'm reading per winding. So I'm reading about 32 ohms on that winding and about 22 ohms on the other. So that seems to be in a normal range for a quarter horsepower motor. Larger horsepower motors will actually have less resistance for their windings, but in the case here that seems normal, so it definitely is the capacitor. And the 5 microfarad portion of the capacitor is for the fan motor, and it was only registering 3.7, which is well under what it requires, so that's why it's not developing any torque at startup. So I'm just going to install the new one, and make sure to note where the common is versus where the fan and the actual compressor get hooked up. And we're just going to mount this back into the unit, and once that's done, we're going to hook it back up. And once that's mounted in place, we're just going to hook up the wires. So the yellow is our common lead, so we're going to hook that to the common terminal. Blue is for our compressor. And the brown wire is for our fan. So even though the capacitor wasn't 100% bad, the less capacitance it had for the fan motor was insufficient for the starting and running of the motor. The fan motor in this one is a permanent split capacitor run motor. And without sufficient capacitance, it was unable to develop the torque in order to spin the fan. If you are to leave your motor in that state, where it's not turning and making that noise, it will damage the motor. And with the cover being fully installed, we're going to turn on the power and test this unit out. And with the disconnect switch turned back on, there she runs, no more noise, fans turning, heat pump is working. Thanks again for watching The Random Robot. If you have any suggestions for future videos, please leave them in the comments below.